Here's problem 19 from the 2023 AMC 8. An equilateral triangle is placed inside a larger equilateral triangle, so that the region between them is divided into three congruent trapezoids. The side length of the inner triangle is 2/3 the side length of the larger triangle. What is the ratio of the area of one trapezoid to the area of the inner triangle? You can pause here and solve the problem before seeing the solution. Let's draw it. Here is the large equilateral triangle, and inside it the smaller equilateral triangle. Connecting the corresponding corners splits the region between them into three congruent trapezoids. The key fact is that the areas of similar triangles scale as the square of their side lengths. Let the large triangle's area be t. The inner triangle has side 2/3 of the large one, so its area is 2/3 squared times t, which is 4/9 t. The region between the two triangles is the large area minus the inner area. T minus 4/9 t equals 5/9 t. That region is made of three congruent trapezoids, so one trapezoid is 1/3 of it, which is 5/27 t. Now take the ratio of one trapezoid to the inner triangle. 5/27 t to 4/9 t. The t's cancel. Dividing 5/27 times 9/4 gives 5/12. So the ratio is 5 to 12. The answer is 5 to 12, choice C.